In section 3.2, we're going to look at what is called the remainder theorem. Let's say we're asked to divide the polynomial x squared plus 7x plus 17 by the binomial x plus 3. Well, you may have done this process of long division back in pre-calc 20. But when I'm dividing, basically ask yourself, how many times will x divide into x squared? Or basically, what do you have to multiply x by to get x squared? And that answer is x. And then when I multiply x by 3, I get 3x. So I'll put that under the 7x. When I multiply x by x, I get x squared. And then I am going to subtract the x squared plus 3x from the x squared plus 7x. So x squared minus x squared, that's going to be gone. 7x minus 3x is going to be 4x. Now I'm going to bring down the 17. And again, you ask yourself, what do you have to multiply 4 by to get 4? What do you have to multiply x by to get 4x? That answer would be plus 4. 4 times 3 is going to be 12. 4 times x is going to be x. And if I subtract 4x, subtract 4x is gone. And 17 subtract 12 is going to be 5. So this guy right here is going to be my remainder. So basically, what you're going to see in the next slide is we took a polynomial, which was x squared plus 7x plus 17, and we'll call that polynomial p of x, and we divided it by a binomial, which we'll call x minus a, and we ended up getting a quotient, which we'll call q of x, plus our remainder over our divisor. Okay, so how does this work for there? How can we write this question in this form? Well, to do that, it's going to look like the following. It's going to be x squared plus 7x plus 17 divided by x plus 3 equals my quotient, which was x plus 4 plus 5 over my divisor. So that is how we will write an answer when we divide a polynomial by a binomial. Okay. Now, an easier way to do long division is to use a process called synthetic division. And I'm going to do the same question using synthetic division and show you that it can be done a little bit quicker. Okay. Now, in synthetic division, there's a couple of things. Number one, the polynomial has to be written in descending order. And that's when we're talking about the powers, of course. And the second rule is, we have to use a 0 as placeholders. So for example, if my polynomial went from an x cubed all the way down to an x, we would have to put in a 0x squared in our synthetic division. Okay, here's how the synthetic division works. Okay, I'm going to take the coefficients that are in front of my original polynomial. So there's a 1 in front of the x squared, there's a 7 in front of the x, there's a 17 as a constant, and I'm going to put the value that makes x plus 3 equals 0, which is -3. Then I'm going to leave a line, and I'm going to draw a line, and this 1 is going to come straight down. -3 times 1 is going to give me -3, and if I add those up, 7 and -3, I get 4. -3 times 4 is -12, and if I add those up, I get 5. So this number here is my remainder. And really what we did in our synthetic division is we took an x squared, which is the highest power of my polynomial, and I divided it by a power of x. So that means that this 1 down here is going to be my variable x, and the 4 is going to be my next power less than x to the first, which is just a constant 4. So therefore, my answer is going to be x plus 4 plus my remainder was 5 over my divisor of x plus 3. So I get the exact same answer, just in a little quicker format. All right, so let's go through the next example. It says we want to divide the polynomial p of x by x minus 1, express it in the form that we're used to here, and then we're going to identify any restrictions on the variable, and then we're going to verify that our answer is correct. Okay, so to start with, we're going to use synthetic division. I'll make a little step. And the number that makes my binomial x minus 1 equal 1 is going to be, or 0, sorry, is going to be when x is 1. And then if you notice, my polynomial is written in descending order. So I'm going to have a 1 in front of the x to the 4th, a negative 2, I have a 1, a negative 3, and a 4. So I'm just taking the coefficients of my polynomial and writing them down. So now I'm going to leave a line. This first guy drops straight down. And I'm going to multiply this by this. And 1 times 1 is going to be 1. If I add those up, I get negative 1. And 1 times negative 1 is going to be negative 1. If I add those up, I get 0. 1 times 0 is 0. If I add those up, I get negative 3. And 1 times negative 3 is negative 3. And if I add those up, I get 1. So this guy right here is going to be my remainder. And these are going to be the coefficients of my quotient. And it's going to be start with 1 power less than my original polynomial. So since I started with an x to the 4th, this guy here is going to be an x cubed. This would be an x squared. This would be x, and there would be my constant. And I'm just going to put a plus in there for the 0. So there's going to be my answer. So if I want to write this in the form they want me to write it in, I'm going to have to write it, first of all, as the polynomial, the original polynomial, x to the 4th minus 2x cubed plus x squared minus 3x plus 4, all divided by x minus 1, and that equaled my answer down here, which was x cubed minus x squared minus 3 plus 1 over my divisor, which was x minus 1. So there's my answer written in the form here. So that's part A. Part B, they want me to list any restrictions on the denominator and the variable. Well, the only value x can be is x cannot be 1, because then I'm dividing by 0. And now they want me to verify that this is correct. Well, to verify it, I want to get rid of my fractions in this equation. So I'm going to multiply every term by x minus 1. Multiply this guy by x minus 1. And this guy by x minus 1. So in this term, these are going to cancel. In this term, these are going to cancel. So what I have to end up doing is multiply this trinomial by that binomial, add 1, and see if I get the polynomial on the left. So I have x to the 4th minus 2x cubed plus x squared minus 3x plus 4. And now I'm going to distribute this x into the trinomial. So that's going to give me an x to the 4th minus an x cubed minus 3x. Then I'm going to distribute the negative 1 to get a negative x cubed plus an x squared plus 3. And I still have this plus 1 from over here. So now let's gather like terms on the right-hand side. So I get an x to the 4th. I have a negative x cubed, and a negative x cubed is a negative 2x cubed. I have a positive 1x squared. I have a negative 3x, and 3 and 1 adds to 4. And you notice these are the same. So I verified that my solution is correct. All right. I want you now to try to use synthetic division to divide the following. So again, we'll do this one together, and I'll let you try the next one. Okay, so first of all, make our little step. and ask yourself what makes x plus 2 equal 0. Well, that's when x is negative 2. Then I check my polynomial to make sure it's going down in descending order, and it is. So now I just take those coefficients in front. So 2, there's a 1 in front of the x squared, 4, and negative 10. Leave a line, drop this guy straight down. Negative 2 times 2 is 4. 1 and 4 is 5. Negative 2 times 5 is going to give me negative 10. 4 and negative 10 is negative 6. Negative 2 times negative 6 is 12. And my remainder is 2. All right, so oh, I think I made a mistake here. This should have been a negative 4. Let me back this up. Sorry. My mistake. So I pause there. Okay, let's go back. 1 and negative 4 is negative 3. Negative 2 times negative 3 is going to give me 6. 4 and 6 is 10. Negative 2 times 10 is going to be negative 20. So my remainder works out to be negative 30. Okay? Now, I started with an x cubed, so that means my quotient is going to be 1 power less. So this is really 2x squared minus 3x plus 10. And my remainder is 30 over x plus 2, and there would be my final answer. Okay, I encourage you to pause the video and give this one a try. Okay, hopefully you've had a chance to try this one. Again, the value that makes x plus 2 equals 0 is going to be negative 2. And again, be sure to rewrite this polynomial in descending order so that you have the right numbers in your synthetic division. So now it's going to be 1, 6, 11, and 6. This drops down. And negative 2 times 1 is going to give me negative 2. If I add those up, I get 4. Negative 2 times 4 is negative 8, so I get 3. Negative 2 times 3 is negative 6, and I get 0. So there is no remainder, so that means that x plus 2 must be a factor of the polynomial. So I am left with my original divisor, which was x plus 2 times, okay, well, this guy here, again, I started with an x cubed, so the 1 is going to be the coefficient in front of the x squared. 4 is going to be the coefficient in front of x, and 3 is a constant. Now, I hope you notice that that is a quadratic that can be factored. So those are the 3 factors of that polynomial. So if you were to FOIL those all out or multiply them all out, you'd have to FOIL the first 2 and then distribute the x plus 1. You'll get back the original polynomial. Okay, again, I'll pause the video. You guys give this a try. Okay, hopefully you've had a chance to try this one. So again, you're going to ask yourself, what makes x minus 2 0? That's going to be 2. And my coefficients, 1, 7, negative 3, and 4. And that polynomial is in descending order, so all is good. Leave a line, bring down the 1. 2 times 1 is 2. 7 and 2 is 9. 2 times 9 is 18. That's going to be 15. 2 times 15 is 30. So my remainder is 34. So therefore, my final answer is going to be 1x squared plus 9x plus 15, and my remainder is 34 over x minus 2. Okay, now let's look back at our last example. We were asked to divide x cubed plus 7x squared minus 3x plus 4 by x minus 2. Okay? What if we evaluated our polynomial at x equal 2? So let's say we have our polynomial, we're plugging 2 in for x. I get 2 cubed plus 7 times 2 squared minus 3 times 2 plus 4. So this works out to be 8 plus 28 minus 6 plus 4, which is 36 minus 2, which works out to be 34. Well, notice that value is the same thing as my remainder when I did the synthetic division. So there is a relationship between the value that makes my binomial 0, which in this case was 2. I could do the long division to figure out my, or synthetic division, sorry, to figure out my remainder, or I could just plug 2 into the polynomial for x, and that value will also be the remainder. So that's basically what the remainder theorem says. It says the remainder theorem states that when a polynomial in x, p of x, is divided by a binomial of the form x minus a, the remainder is going to be the same thing as just substituting the value of a into x in the polynomial, just like we did in the previous example. All right, so this question now, we're going to use this theory to help us with these questions. It says for each dividend, determine the value of k if the remainder is negative 2. So if I'm dividing 2x cubed minus 5x squared minus 4x plus k by x plus 1, and I get a remainder of 2, that means if I plug in negative 1, which is the value that makes my binomial 0, if I plug negative 1 in for x in the polynomial, it should equal the remainder, which is negative 2. So this ends up being negative 2 minus 5 plus 4 plus k equals negative 2. So the left-hand side is going to be negative 7, and negative 7 plus 4 is negative 3. And if I add 3 over to the other side, I'm going to get the value of k to be 1. Okay, I would like you to try the second one. So again, pause the video and give it a try. Okay, well, hopefully this time you saw that the value that makes x plus 2 0 is negative 2. So if I substitute negative 2 in for x, I should get the remainder, which again is negative 2. Negative 2 cubed is negative 8 times 3. This will be negative 24 plus 4k plus 26 plus 4 is equal to 2. So this is going to be 2 plus 4 is going to be 6. So this time, I end up getting, well, this should be a negative 2, sorry. So when I subtract over 6, that becomes negative 8. And dividing, I'm going to get k is negative 2. Okay, so the remainder theorem, the shortcut is if you take the value that makes your dividend 0, plug it in for x in the polynomial, whatever that answer is, that is your remainder if you did synthetic division. Okay, so that ends this lesson on section 3.2, the remainder theorem. So there's some questions for you to try, and we'll take up any problems you have in class.